I'd like for us to consider a very, very common question that we're going to see for the rest of the semester, which is how do I evaluate the composition of a trigonometric function on an inverse trigonometric function? So with that in mind, the general composition of these things is that you are going to see a trigonometric function composed on an inverse trigonometric function. Now the input to a trigonometric function is supposed to be a ratio. The output of the inverse trigonometric function, this guy right here, should be an angle. Once we figure out what that angle is, we then take the trigonometric function of that angle and we get a ratio. So these problems are going to be a fancy form of given one trigonometric ratio, see if you can determine another trigonometric ratio for a given angle. So the procedure is going to go as follows. Label the output of the inverse trigonometric function as an angle and give it a name. Now by a name, I don't mean a name like Jim or Bob or Jim Bob. I mean give it a name like a Greek letter, like theta or alpha or something along those lines. So that just means identify something as an angle and give it a name. Then we'll relabel the problem with the angle name. Once we do that, again, we will have one of the ratios for the given angle. So draw the angle in the appropriate quadrant. Now, the quadrant in which you draw this angle is going to be based off of the angle restrictions associated with the inverse trigonometric functions, so it is going to be important to know all of those restrictions. Once we do that, we're going to draw the appropriate reference triangle and label two sides. The two sides that you're going to be labeling will be based off of the inverse trigonometric function that you know. Once you've labeled two of those sides, you now know two sides of a right triangle. What's for dinner? Once I say you have two sides of a right triangle, it doesn't matter what the next question is. The answer is automatically the Pythagorean theorem. And then finally, identify the desired ratio. That is to say, after you've labeled the triangle, you're still trying to find a trigonometric function of whatever that the inverse trigonometric function is. So identify the desired ratio, and we're set.